We can combine functions using addition, subtraction, multiplication, and division by performing operations with the algebraic expressions. We did this in section 5.1, subtracting revenue and cost to create a new function, the profit. When we create a new function through addition, subtraction, and multiplication, the domain of the new function will be the combination of the domains of the original two functions. When we create a new function through division, the domain of the new function is the combination of the domains of the original two functions, and also excluding where the function in the denominator is 0. So in example 2, we're going to let f of x equal 2x minus 1 and g of x equal x squared plus x minus 2. Okay, and the first thing we're asked to do in part A is to find f plus g of x. So f plus g of x, we want to take the function f and add it to the function g. Okay, so since we're adding, these parentheses don't do anything for us. We can just add our like terms directly. There's only this x squared term, so this will equal x squared. For x's, we have 2x plus x, so that's 3x. And then our constants, negative 1 minus 2 is negative 3. So f plus g of x is x squared plus 3x minus 3. The domain, we want to combine our original two domains. 2x minus 1 has no denominator and no square roots, so all real numbers. And g of x, no square roots, no denominators, so all real numbers. So combining all real numbers with all real numbers, our domain is all real numbers. Second thing we're asked to do in part B is to find f minus g of x. F minus g of x, we want to take our function f and subtract the function g. Here we have to be careful because of the minus sign. This second set of parentheses is important. We're subtracting this entire set of parentheses. Everything inside needs to be subtracted. So 2x minus 1, we want to subtract x squared, subtract positive x, and subtract negative 2. Two negatives will make this a plus 2. Combining like terms, this is the only x squared term, so minus x squared. 2x minus x is 1x, or just x. And negative 1 plus 2 is positive 1. Okay, like part A, since the two original functions, the domain is all real numbers, the domain of our new function is all real numbers. Question C, we're asked to find f times g of x. So here we want to multiply our two functions. So we're taking 2x minus 1 and multiplying by x squared plus x minus 2. So this is basically a FOIL problem, except our second parentheses has 3 terms instead of 2. We'll take 2x multiplied by x squared, and that's 2x cubed. 2x times x is 2x squared. 2x times minus 2, minus 4x. Next term, minus 1 times x squared is minus 1x squared. Minus 1 times x is minus 1x, or minus x. And minus 1 times minus 2 is plus 2. Combining our like terms, 2x cubed plus 2 minus 1 is 1, x squared. Negative 4x minus x is minus 5x plus 2. Our last part, part D, we're asked to find f over g of x. So this is division. We're going to take the function f, 2x minus 1, and divide by the function g, x squared plus x minus 2. Okay? So there's our solution. Only thing left to do is figure out when does the denominators equal 0. And we want to exclude those from our domain of all real numbers. X squared plus x minus 2, okay, equals 0. Factors of negative 2, if I use 2 and minus 1, this will factor into x plus 2 and x minus 1. So we want to exclude negative 2 and positive 1 from our domain. Okay, so domain of all real numbers, we want to take out negative 2 and 1. So negative infinity, stop at negative 2. Union, start at negative 2, stop at 1. And then 1 to infinity. Example 3, our functions for this problem are f of x equals the square root of x plus 3, and g of x equals the square root of x minus 2. Okay, we're asked to find f plus g of x. So this would be the square root of x plus 3 plus the square root of x minus 2. Okay, and there's nothing that you can do to simplify that because these two square roots are different. Okay, but for our domain, this is the part that requires the most thought on this problem. Okay, if I look at the domain of f, the square root of x plus 3, we need to have x plus 3 greater than 0. Sorry, greater than or equal to 0. Okay, because we don't want to have negatives under a square root. If we solve this, we get x is greater than or equal to negative 3. For g, x minus 2 is greater than or equal to 0. If we solve this by adding 2, we get x is greater than or equal to 2. So we want to combine these into one single domain. If I look at this on a number line, okay, our first inequality says that x has to be greater than or equal to negative 3. Okay, so that's this part of the number line right here. Our second inequality is that x has to be greater than or equal to 2. If I graph that, that's this part of the number line. Okay, so when we combine these two, there's this entire region here that works for f, but does not work for g. When we combine, we want something that works for both functions. So we want to take the higher value of 2. So our domain for f plus g has to be from 2 to infinity.